Good morning and good afternoon. My name is Jocelyn Sanchez, and today I will be talking about the climate change and ecological impact on baleen whales. In this slide, I will be talking about the background and context of baleen whales. Baleen whales have a lifespan of 40 to well over 100 years and experience more environmental variations in their lifetimes than other species. Baleen whales influence the ecosystem and carbon dynamics from their enormous size and wide distribution. Baleen whales feed primarily on krill and euphausiids and undertake extensive seasonal migrations between low-latitude breeding and high-latitude feeding grounds. They are able to store carbon in their biomass and contribute to carbon export through sinking carcasses. And baleen whales play a great role in the ecosystem, which can result into a devastating ecological impact in the future if they are not able to adapt to climate change. For a brief definition, I have decided to include krill, also known as euphausiids, which is the primary food for baleen whales. Another definition that I recently learned while reading the research papers were phenotypic plasticity, which is a species' ability to produce phenotypes in response to environmental variation. In this slide, I will be talking about the climate change impact on baleen whales. Research shows climate change influences breeding success by determining variation in food, also known as krill availability. With warmer ocean temperatures and global warming, baleen whales have had to adapt their seasonal movement to the shift in productivity in the North Atlantic. There could be an increased competition for krill prey by initially recovering whale populations, which may be the driving force of some of the projected further declines in both krill prey and whale predators. Another also known impact is the increased sea surface temperature may be a potential driver behind a northward shift of the whale distribution. In this slide, I'm going to be talking about a research study that was conducted on the climate change impact of baleen whales. In this research study, mice, also known as model of intermediate complexity for ecosystem assessment, was conducted to assess historical whaling and climate change impact. The study also used phytoplankton, krill, copepods, and 5 baleen whale predators as the focus. The 5 baleen whales were the blue humpback, southern white, fin, and Antarctic mink, along with their krill and copepod prey. The results show that there would be long-term and potentially irreversible changes to the physical process and marine environment of baleen whales. It also showed that mink whale numbers are predicted to slow over the next 100 years. And further down, you will see where I've included a figure which shows the estimated trajectory of baleen whales. It also shown declines for Pacific populations of blue, fin, and southern white whales with potential for extinction. And it showed a large decline in both fin and humpback whales specifically, which could change migration patterns in their environment in response to climate change warming. This has been observed in the northern hemisphere with northward shifts in distributions. Another research study demonstrating climate change observed the shift of migration and adaptation to global warming. The target species were fin and humpback whales, where they would spend part of their summer in the Gulf of St. Lawrence. It observed that both of the species left the Gulf of St. Lawrence earlier and arrived in the feeding grounds later. There was also several rare resighting. This demonstrated adaptation to changing conditions and phenotypic plasticity. In this slide, I included both figure 3s of the first research study and the second research study that I have discussed earlier. In the first study, this shows figure 3, and it shows the estimated trajectories of baleen whales. So as you can see, it shows that the blue whale will decrease over time and somewhat begin a bit of an increase in the Atlantic and Indian Ocean, but not much. And with the fin whale, it shows that it's going to keep declining over and over. There will be a slight shift within the Atlantic and Indian Ocean, but overall it will be decreasing in the Pacific Ocean. The humpback whale will initially increase, and then it will go down more towards the end of the next century, and in both the Atlantic and Indian Ocean and the Pacific Ocean. And for the southern white whale, it's going to show a steep increase between 2150, and it's going to start to decline after that, going down back towards where it used to be in 2100 for the Atlantic and Indian Ocean. And for the Pacific Ocean, you can see that there is a sharp decline over the years within the Pacific Ocean. The Antarctic minke whale is going to have a steep increase between 2150 but overall it will end up decreasing as well in the Pacific Ocean. And for the Antarctic krill, it's going to continue to decrease over the next 100 years. For the second study, which it shows figure 3, it shows the departure and arrival times of baleen whales, and in this figure you can see that they start to increase initially, but then it will decrease when they arrive. So you can see it there with this figure. In this slide, I'm going to be talking about the ecological impacts of baleen whales. So baleen whales were once the target of intense commercial hunting and are now recovering in many ocean regions. And this was after laws were in place to be able to protect the baleen whales. Baleen whales serve as sentinels to habitat alteration through changes in their distribution, abundance, phenology, and body condition. Their limited prey availability has been shown to affect body temperatures and fertility. Krill is expected to contract southward due to increasing temperature and reduced sea ice extent in the future. And another ecological impact would be there would be changes in pregnancy rates, which can provide quantifiable signals of the impact at a population level. In conclusion, and from my perspectives, some studies concluded most baleen whale species may benefit from global warming, with the effects of increasing temperature on baleen whale abundance and migration, which can be complex. With further I also believe that if we do not act now with climate change, that this could potentially become disastrous towards the ecosystem, because baleen whales do play a large part into it with their carbon mass and their carbon carcasses. So for me, I would I do think eventually we will see a decline if things continue to trend the same way that they are trending now. But if we do something about climate change, then this could potentially be life-saving for whales and other species. This last slide is my references slide. I included 7 to 8 different references for this presentation. And this is the last of my references. Thank you very much. Have a great day.